Hello everyone, welcome. So today we will be talking about enzyme. So enzyme does not take part in the reaction, but it helps to speed up the reaction. Okay. So in this diagram you see various parts of the enzyme, which is a cofactor. Then we have the catalytic site, which is the active site. Then we have a coenzyme, part of the enzyme, and the apoenzyme. Now, what are the various properties of enzyme? We have catalytic property, helps in taking the reaction, speed of the reaction. Reversibility, specificity, enzyme is very specific, the site that it needs to attack. Then heat sensitivity and pH sensitivity. So the enzymes, they are classified based on their functions. Oxidoreductase for oxidation and reduction functions, transferases to transfer a specific group, hydrolases, that is hydrolysis is going to happen, isomerases, the change in the isomers, lyases, which is having the removal of a group, and ligases, which is joining of the groups. So we can classify enzyme as simple enzyme and a conjugated enzyme. So simple enzyme, it's made up of only proteins like pepsin, trypsin. Conjugated enzyme, they may be made up of a protein and a non-protein part. So the protein part is the apoenzyme, and the non-protein part can be coenzyme, cofactor, and prosthetic group, or it can be combination. So coenzyme, they are loosely attached organic part of the enzyme like vitamins, AMP, ADP, and all those things. Then we have cofactors, which is basically inorganic or metallic ions. And then we have prosthetic group, which is tightly attached, and there are many inorganic part which cannot be easily separated. So that is the prosthetic group. How does enzyme act? So as the substrate and the enzymes, they reach their activation energy, they reach an optimum stage of energy. So once they reach the activation state, they will combine, they will form the complex, and then they will be forming the product. Now there are various hypotheses how the enzyme acts. So first hypothesis that I will be going ahead with the lock and key. So we have the enzyme, we have the active site here, and we have the substrate. So what is happening? Substrate is coming and binding, because it is very specific, the active site, it is going and binding, and then it is forming the product. Okay, whereas induced feed is what? So we have the substrate which is coming and binding the active site, so it is forming a complex, or there is a conformation change that occurs, and then they are forming the products. Okay. So there are various inhibitions. One of the major action is inhibition. So in inhibition, what happens? Competitive inhibition we have. So competitive inhibition, in competitive inhibition we have an active site, and the inhibitor and the substrate will go to the same active site. So once the inhibitor goes and binds, well, the substrate will no more be able to bind. Then we have non-competitive inhibition, whereas a non-competitive inhibitor is coming and that is changing the active site of the enzyme, so the substrate cannot come and bind. So this is non-competitive inhibition. Okay, now the next is Michael-Menton's equation. This is how it goes on, where V is equal to V max S by Km plus S. So when there is no S, V naught is 0. Okay, and when S is maximum, V reaches the V max. So what happens is, so this is the action which is going on, this is the substrate, and here we have the V. Whenever it reaches V max, just take the half of it, V max by 2, and just bring it down, this will be the Km. Okay, so that is how we get this equation. So that's it in enzymes. Thank you.